Excellent. So for today's lecture, I want to pick up where we last left off. So we had started what I call Unit 2 inside of this course, 2120, where we're examining the collections framework and generics. And for today's lecture, I want to focus in on the Iterator interface and the Iterator objects in Java. So let's take a look. So off to the side there. Okay, perfect. Okay, so an iterator in Java is a special type of object that provides sequential or one-by-one access to the elements of a collection object. So in simple words, it's an object that allows us to get and process one element at a time. And it was first introduced in Java 2 when the collection framework was introduced. So an iterator object implements the Iterator interface, which is present in the java.util.iterator package. Like we said, all of the collections framework stuff is located inside the java.util package. So when we go to import the Iterator interface, we could either do it via java.util.iterator, or we could do it as java.util.star. Typically, it's better to use the more direct approach, so that way you know exactly what classes you're importing into your Java code. So the iterator in Java is used in the collections framework to retrieve elements sequentially, like we said, one by one, and it's typically called the universal iterator or cursors. It can be applied to any collection object. By using iterator, we can perform both read and remove operations on our collections. So the iterable interface in Java, the collection interface extends iterable interface that is present at the very top of the collection hierarchy. Let's actually make that up. There we go. The very top of the collection hierarchy. The iterable interface is present in the java.lang iterable package. It provides a uniform way to retrieve the elements one by one from a collection object. It provides just one method named iterator, which returns an instance of iterator and provides access, again, one by one to the elements in the collection object. Hence the term iterator. The general syntax of the iterator method is as follows. So when we invoke iterator, it will return an instantiated iterator object for us. So we never have to use the constructor to get ourselves an iterator. This is what we call in software engineering a factory pattern, where we invoke a method and the method returns to us a pre-built instance so that we don't have to know how an iterator gets built. We just get it and then we can use it. So how does the Java iterators work internally? Well, the basic working mechanism for using the Java iterator is shown in this flowchart. So here we have our collection object, and this could be a list or set or what have you. And so we call the iterator method, which creates an object of the iterator. So this will create an iterator object that iterates on this particular collection. So this collection gives us an iterator for it. And then we can then use the iterator object to actually walk across the collection. So we can ask the iterator, hey, is there a next thing? Kind of like not indifferent to like how we could use scanner to ask scanner, is there another token inside of the input stream? And if there is, and we can do something, we can ask the iterator, is there a next element inside of the collection? And if it's false, if there's no item that's next in the collection, then we could say, oh, well, there's no more elements of element. But if this is true, then we can make a successive call on next, just like scanner. So scanner is very similar to what an iterator object is, only it iterates across your input stream. Here, this is like a scanner, but it iterates across your collection object. So here, for each successive call of the next method for the iterator, it returns whatever that element is until you run out of elements. So a quick example of the iterator test here is if I have my if I import ArrayList, and if I import my iterator, and let's say I call this public class iterator test1, and I have a main method, and in my main method, I'm going to create a new ArrayList that's going to hold data type string. That's what I'm going to declare inside of this. Here, let's actually update this so it uses the diamond operator. Okay, so I'm going to create an array list that holds string, and then I'm going to add to that array list A, B, C, D, E, and F. I can then ask the array list, since it is a member of collections, for its iterator. And here, when I go and declare my iterator variable, just like I'm using the type parameters to say that this array list holds strings, I'm going to also do the same thing for my iterator. It's going to create an iterator that iterates for strings using the generics syntax. And then while iterator has next, so this will return true or false, we'll grab the next thing that the iterator points to, and then we'll print that to system.out. And so if we want to go ahead and see the output would then be A, B, C, D, A, B, C, D, E, F. And again, if I actually want to test that, I can run over here. Let's see here. Let me go to my iterator test, and let's run this code. And here you can see, yep, A, B, C, D, E, F. So when we create an iterator for the collection elements, the iterator looks like the following effectively. So here we have our array list, and then we have a cursor, or the iterator, starting at the beginning position. And then when we request has next, the method is called on the iterator, and it returns true because there is an element present in the forward direction. So the iterator goes in the forward direction from the collections perspective. And with the call to next method, it returns the element from the collection, and then it advances the iterator object to the next element on the next call of this method. So then when we say, again, has next, well, since B is there, then it will return true again. And then inside the while loop, we'll go ahead and invoke the next method, which will then return the value, the element of B, and then advance the cursor by 1. And we'll continue to do that until the cursor reaches the last element of the array, until it reaches all the way here. And then when we invoke has next, it will return false. And so that's our loop control that stops our loop control, right? Our loop control variables effectively that call to has next. So once that returns false, we stop executing that while loop, and then we exit out. So that lets us walk across this array list using an iterator. Now, the beautiful thing about an iterator is we can use an iterator for any type of collection type. So it defines a uniform set of logics on how we can walk through any collection. So the Iterator interface provides 3 methods in Java, and they're as follows. It's a public Boolean has next. And so this method will return true if the iteration has more elements to traverse in the forward direction, and it will give false if all the elements have been iterated. It has a next method. So the next method returns next element in the collection. It will throw no such element exception when the iteration is complete. And it has a remove method, and the remove method does not have any return type here, and it removes the last of the most recent element returned by the iterator, and it must be called after calling the next method, otherwise it will throw an illegal state exception. So let's take some example programs based on these methods in an easy step-by-step way to kind of see how they actually work. So here we have, in this example, where we will iterate elements and then remove the odds. So just taking a look at the source code, I'm going to import an array list. I'm going to import the Iterator interface. I'm going to create a public class Iterator test2. Here, I'm going to make a main method that we can go ahead and test this out. I'm going to instantiate an array list. This array list is going to hold data type integer. Now recall, since ints are typically primitive data types, we have to use the reference data type because array list requires an object, a reference to an object. But because of auto boxing and unboxing, we can easily convert between primitive data types and its reference counterpart. And then we're going to do just a for loop here. So we're going to create a loop control variable starting at 0. As long as our I is less than or equal to 8, we'll increment it. And then what we'll just do is add that value, that integer, into our array list so that our array list will have the values of 0, 1, 2, 3, 4, 5, 6, 7, and 8. And then what we're going to do is we're just going to print out the state of our array list. Then we'll go ahead and we'll ask the array list for an iterator object. And so we're going to save that iterator object into memory. So again, we're going to declare an iterator variable. And every time we declare an iterator variable, we want to ensure that we declare what data type the iterator is going to return to us, just like we want to declare what data type the array list is going to hold for us. And then we're going to do a repetition structure here. So long as there is a next element in the iterator, we're going to grab that value. And here we're going to store that as a reference data type. We could have done either way, though. It doesn't matter. We could have done this as an int as well. It would have unboxed that for us. Then we'll print that value out. And then we're going to evaluate if the value is odd. So if mod 2 of the value that we grabbed from the array list is not equal to 0, then we're going to remove it from the iterator. Otherwise, and then after that, regardless, we're going to print the state of our array list. So a quick example of what's happening here, and then we'll look at the output in just a moment, but to look at the below picture to understand how the elements are iterating in the above program. So again, this is our array list, and this is our iterator, and the cursor starts at the 0th index, before the 0th index. And then after calling next, so we would do has next, and this would say, oh, yes, that's true. And then we would call the next method, and it's going to advance our iterator. It's going to advance the cursor by 1 to now have index value number 1 in front. And then for each call of next, we keep advancing that iterator. But when we go to invoke the remove, what it's actually going to do is it's actually going to do like a back delete. It's going to go back and it's going to remove the element in between the 2 and 0. So this is kind of a conceptual view of how it advances. And then when you tell it to remove, it goes back and then can have the value not be in the iteration process. So, but again, what's interesting here is when we call the system.out on the array list, let's see what actually prints out there. So our output to this would be start at 0, 1, 2, 3, 4, 5, 6, 7, 8. And again, looking at this, let's look at where our system.outs are. So our system.outs right here, when we will initially print out all the elements in the array. And then we're going to enter the while loop, and then we're going to print out a singular value, the value we're pulling out the array. And then after we make a decision, hey, is this integer value, is I mod 2 not equal to 0? Well, if it is, we'll go ahead and remove it. And so then we'll print out the new state. So let's look at the output. So here we're going to print out the full state, and then we're going to go ahead and grab the first element using the iterator. That's going to be 0. Then we're going to say, hey, is that odd? And it's not odd, so we don't modify using the iterator our array list. So it maintains the same. Then we grab the next element, 1, and then we're going to go ahead and say, hey, is that odd? It is. So we do use that remove method, and then we print out the new state, and notice the array list now has removed that 1. So 0, 2, 3, 4, 5, 6, 7, 8. And then we'll advance to the next element, which is now going to be the 2 element, the element with the value of 2, because the 1's been removed. And then well, that is even, so it's going to maintain the same state. Then we'll advance to 3. Well, that is odd, so we're going to tell it to remove it. So when we print the new state, now it's 0, 2, 4. And then we'll advance to 4. That's even, so it maintains that state. Then the iterator advances to 5. Well, that's odd, so it's going to remove that. So now the new state has removed the 5. Then we'll move to the 6, where that goes ahead and is even, so it's going to maintain. And then we'll advance to the 7, which is odd, so it's going to actually remove that, use the iterator to remove that. Finally, we'll go to the 8, and that's even, so that's going to maintain the state. After that, there's no more elements, so we stop the execution of our program there. So that's just an example of how we can go ahead and use an iterator to actually remove elements as well, to kind of mutate the state of our array list. Here I want to show you another example, how we can iterate all elements in array list using the iterator. So here we have an array list that will import. We have the collection interface that will go ahead and import, and we have the iterator interface that will go ahead and import. And so we'll call this class iterator test number 3. Here we'll make a main method. Inside of here, we'll create a new array list, but we're going to hold it as a collection data type, because an array list implements an array list, implements a collection. Therefore, it could be a member of collection. Therefore, we can store an instance of array list in one of its parent classes data types. And so for our collection variable, we will add red, green, black, white, pink. Then we'll ask this collection, hey, collection, give us a instance of an iterator, and we will store that iterator into a variable. And then we'll do the same thing. We'll create a while loop. While the iterator has another value, we will just go ahead and print that next value. And since it's a string, we can do like all the normal calls you would do to a string. So this is called chaining methods if you haven't seen it before. So on iterator has a next method. The next method is going to return a string. We know it's going to return a string because that's the type parameter here, right? This is an iterator for string elements. So this is going to return back a string data type. Well, we know on a string data type, we can go ahead and invoke a toUpperCase method. So we'll chain these methods together and print those out. And then we'll just go ahead and, well, I don't want to do that, print a new line after that. And so the expected output for that would then be red, green, black, white, pink. And again, if we want to see that in practice, we can just go, what is that? That's my iterator test 3 here. And we can just test this out. We can actually see that will give us red, green, black, white, pink, just as we'd expect. Okay, so Java Iterator has the following advantages. An iterator can be used with any collection classes. We can perform both read and remove operations with the iterator, and it acts as a universal cursor for the collection API. So some limitations of the iterator in Java, some drawbacks or potential drawbacks are that by using iterator, we can only move in the forwards direction. We cannot move in the backwards direction. Hence, the universal iterator is considered a single direction cursor. We can perform read and remove operations. However, we cannot perform replacement of new objects, right? So we can either get an item or we can remove it, but we can't set an item into the collection with just the iterator object. But that's where we'd want to look at a more specialized iterator. So for example, go into this example with mangoes. Suppose you had 5 mangoes in a box, and out of the 5, you had 2 mangoes that were spoiled, and you want to replace those with an iterator. You couldn't do that. But to overcome that drawback, we can use a more particular or specific iterator, if it's on an array list at least, which is called a list iterator. So the advantage of an iterator is it can be used on any data type, but if you know a little bit more about your collection data type, well, I'm sorry, it could be used on any collection type. But if you know a little bit more information, if you know that the type, your collection type is a list iterator, it might be better to use the list iterator instance, because it can give you a little bit more flexibility with what you can do. So with that said, I'm done with iterators. I'm ready to move on to list iterators. Does anyone have any questions about what we just talked about with iterators? And if not, I'll move on to the next topic.